All right. So I don't know if you've ever seen a problem like this, but sometimes they bring them up, and you kind of have to figure out what the red flower equals, and then once you know what the red flower equals, you can start to find out what the blue flower equals. Anyways, I want to relate this back to what we are working on. So we're going to take a look at this. And there's a couple different terms that we want to talk about. So an expression is where there is no equal sign. So when we talk about an expression, it's a mathematical statement with no equal sign. So a mathematical statement with no equal sign. Okay, so it's just writing out a bunch of stuff. And what we see are we have what they call three terms. And a term is differentiated by a plus or minus sign. So a plus or minus will break up each term. So when we have this type of situation, you might see like 3x plus 5, and you can see there are two terms there, okay? Now, when we have a variable, that is a letter to use for an unknown. Now, they don't always have to be letters, but I want to say 99% of the time they're going to be letters, okay? So when you see these flowers, really you want to think about it as x plus x plus x, all right? And if we put those together, or we put the three flowers together, we come up with three flowers, right? Well, if we put the three x's together, we come up with 3 times x. So how do we know this? Well, what happens if we do 2 plus 2 plus 2? Don't we get 2, 4, 6, right? And if you think about it, if we do 2 added together 3 times, isn't that the same as trying to imply 3 times 2? And isn't 3 times 2, 6? All right. So with that type of situation, like that's how we are looking at this. So the coefficient is the number in front of the variable. And we talked about the variable. Go back up to here. The variable is the letter to use for an unknown. So the 3 in front of the x is what we call the coefficient, and then the x itself is the variable. So we're trying to interconnect all of these different ideas, okay? So we have to have that kind of information in order to continue on and solve these types of problems. So for this one, an equation is where we use an equal sign to solve for an unknown. And that unknown we are going to say is a variable. Okay, so once again, we had x plus x plus x. So that gave us 3 x's. Okay, and then we could set it equal to 60 and solve it. However, we're not solving things today. I wanted to talk about the definition of an equation versus the definition of just an expression. An expression, we don't have the equal sign, where the equation we do. So when we look at these types of expressions, we want to simplify. So we want to combine or put together all of the similar things. I thought about it as like classifying animals. Back in the beginning days, you just look around and say, oh, I saw this same animal. And how many times did I see it? So when we do that, we want, say, 1, 2, 3 of these flowers, which we did already. But That's what we're doing when we simplify this expression. Now, for the next one, though, we have one red flower, but we have two blue flowers. So we're combining these two terms together. And that's because they are the same kind of flower versus the red one. So when we're simplifying expressions, you kind of want to group the same things together. Now, when it comes to going on to a math problem with like simplifying where they could put x and y, xy squared, xy squared, and x and y, we want to group these together, kind of that same idea. So I put a red flower for this one and a red flower for that one because they're both just x and y, where this one I put a blue flower because it's xy squared, xy squared. So when we combine these like terms, or we combine these similar figures, we want to put the coefficients together. So if I did 10, a positive 10, minus 4, or I do a negative 4 plus 10, think about it either way. I think one of them is definitely easier to solve than the other. So when we think about a positive 10, take away 4, that leaves us with 6 red flowers. Okay, and then we have the 5 blue ones plus the 11 blue ones, which will make us 16 blue flowers. So when we combine these two different things, that's what we're trying to do. We're trying to put all of the same thing together, same kind of idea together. So for this one, it would be 6xy plus 16xy squared. And these are two different flowers or two different objects. So we don't combine those two together because they are two different ideas. So when we're classifying these things, we wouldn't classify the red flowers along with the blue flowers and combine them together and say, well, they're all flowers. Now we got to back it up because we want to be even more specific than that. So we're just going to combine the two red ones together and then the two blue ones together and leave it as red and blue. And it's just different on how they look. All right, so the last idea we want to touch on is simplifying this, okay? So when we do that, we showed already to kind of create that idea that we're going to put this term, well, let me change the color so you can see it. This term right here, negative 4xy and a positive 10xy, we're going to put those two ideas together, and that's where we created that 6xy. And then the same thing goes for this one, 5xy squared, 11xy squared, and combine those two ideas together. Okay, and that's where we get that final answer. So when we simplify this, we're going to do 10, take away 4, and get that 6xy, and then 11 plus 5 to get 16xy squared. So this is just kind of an intro. We wanted to talk about expressions, combining like terms, and how all that works. So I hope that at least gets you on a starting path, and then we can jump off from there. Make sure to ask any questions if you do. But if not, go on to the next video. All right, so